This question is to use the mean value theorem. Let the function g of x be equal to x plus 1 divided by x plus 3. Part A. Show that the function g of x satisfies the conditions required by the mean value theorem on the interval from 2 to 6. Part B. Then, find all values of c between 2 and 6 that satisfy the conclusion of the mean value theorem. First, verifying conditions of the mean value theorem. We start by checking if the function g of x equals x plus 1 divided by x plus 3 is continuous on the closed interval from 2 to 6 and differentiable on the open interval from 2 to 6. Since this is a rational function and the denominator, which is x plus 3, never becomes 0 within our interval, the function is continuous and differentiable on the required intervals. So, the mean value theorem applies. Next step is to compute the average rate of change. We now compute the average rate of change of g over the interval from 2 to 6. This means we take g of 6 minus g of 2 and divide the result by 6 minus 2. Let's evaluate the function at both endpoints. G of 6 is equal to 6 plus 1 divided by 6 plus 3, which is 7 over 9. G of 2 is equal to 2 plus 1 divided by 2 plus 3, which is 3 over 5, which simplifies to 2 over 45. Next step is to find the derivative of the function. Next, we take the derivative of g of x, using the quotient rule. The numerator of g is x plus 1, and the denominator is x plus 3. Using the quotient rule, we get the derivative of the numerator, which is 1, times the denominator, which is x plus 3, minus the numerator, which is x plus 1, times the derivative of the denominator, which is also 1. So, in the numerator we have x plus 3 minus x minus 1, which simplifies to 2. In the denominator, we have x plus 3 squared. So the derivative, which we'll call g prime of x, is equal to 2 divided by the square of x plus 3. Next step is to set derivative equal to the average rate of change. According to the mean value theorem, there exists some c between 2 and 6 where the instantaneous rate of change equals the average rate of change. So we set 2 divided by the square of c plus 3 equal to 2 over 45. Canceling the 2 on both sides, we get that the square of c plus 3 is equal to 45. Taking the square root of both sides, we get c plus 3 equals the square root of 45, which is 3 times the square root of 5. Then, subtracting 3 from both sides, we find that c equals 3 times the square root of 5 minus 3. To check that this value lies between 2 and 6, the square root of 5 is a little over 2.2, so 3 times the square root of 5 is about 6.7, and subtracting 3 gives about 3.7, which lies in the open interval from 2 to 6. So this value is valid. The value of c that satisfies the conclusion of the mean value theorem is 3 times the square root of 5 minus 3. When solving problems like this using the mean value theorem, especially with rational functions, focus on simplifying the derivative and equating it to the average rate of change. Watch for squares in the denominator and remember to check whether your final c is actually within the interval. That's it for this question.